Since you have understood what is slope and how do we calculate slope and equation, all those things, let's try to understand that suppose if two lines are parallel, then how do we understand the slope? Or what if the slopes are equal, then what do we conclude from that? Okay, things based on this. Suppose say we have two lines. Okay, let's assume that we have the x and y axis. Let's say we have two lines. Let's assume that this is one line. Okay, and say that we have one more line which is going exactly like this. Okay, now here this is theta 1, this is theta 2. Now the lines are parallel to each other. That means theta 1 is equal to theta 2, isn't it? So if suppose say this is L1, this is L2. Suppose if L1 is parallel to L2. If L1 is parallel to L2, then theta 1 is equal to theta 2, or tan theta 1 is equal to tan theta 2. See, tan theta 1 is equal to tan theta 2. So what do we say from this? M1 is equal to M2. This is the condition for two lines to be parallel. Vice versa is also true. In the sense, if two lines are parallel, then M1 is equal to M2, or if M1 is equal to M2, then the two lines are parallel. Both the cases it works. Fair enough? Now, suppose if the two lines are perpendicular, then how do we go about this? We look into this now. Again, we start with the x and y axis. Alright. Now, in this case, let's say the first line, let's assume that the first line is something like this. Okay, let's call this as L1. Okay, now we have another line. Say the other line is going to be something like this. Say this is L2. Now remember, this is making an angle of, so L1 makes an angle of theta 1, which I'm not showing it obviously. Say this is theta 2. Okay, or let's do this. Let's just extend this. Let's call this as theta 1. Okay, theta 1, theta 2. Now what do we know? That this angle is 90 degree, isn't it? Since here we have this angle to be 90 degree, theta 1. See, what do we know from the exterior angle property? What do we say? Theta 2 is equal to theta 1 plus 90, isn't it? Now take tan on both the sides. Tan theta 2 is equal to tan of 90 plus theta 1. So tan theta 2 is equal to minus cot theta 1. Correct? Or we can also write tan theta 2 is equal to minus 1 by tan theta 1. So what do we have? M2 is equal to minus 1 by M1. Now cross multiply, what do we get? M1 into M2 is equal to minus 1. Either we can tell this way, or you can also write this as M1 M2 plus 1 is equal to 0. Now either of these two. Got it? So if two lines are perpendicular to each other, then the product of their slopes is -1. So we can tell this particular case. The product of the slopes is -1. Or you can also say M1 M2 plus 1 is equal to 0. So this is the condition for two lines to be perpendicular. Or we also can call it as orthogonal. Orthogonal is nothing but perpendicular. Got it? Now what we'll do, we'll look into the next case, the more general case. Suppose say if you have two lines, the angle between them is theta. How do we calculate the angle between the two lines? Let's look into it now. Again, we start with the x and y axis here also. So first you have the y axis, you have the x axis. 0. Now first assume that we have a line like this, and say the next one is going to be something like this. So this is theta 1, this is theta 2. Say the angle between the two lines, say this is alpha or something. Okay, some value is alpha. Now here what we are trying to do, we are trying to find alpha, isn't it? Now what do we do? Again, guys, we'll go with the same logic. That is theta 2 is equal to alpha plus theta 1. So alpha is equal to theta 2 minus theta 1. So tan alpha is equal to tan of theta 2 minus theta 1. Now on the RHS it's tan of A minus B. So we have tan alpha is equal to tan theta 2 minus tan theta 1 by 1 plus tan theta 2 into tan theta 1. Fair enough? So tan alpha is equal to m2 minus m1 divided by 1 plus m1 into m2. m1 into m2. So this gives us the angle between the two lines. m2 minus m1 by 1 plus m1 m2. Or you can also write m1 minus m2 by 1 plus m1 m2. That's also fine. That will also work. Clear? This is the angle between the two lines. In this case, we can calculate. Like, see, suppose if 1 plus m1 m2 is 0, that means the denominator is 0, then alpha becomes 90. Isn't it the condition what we just derived before? So based on this, we can calculate. Fair enough? Now, another thing, with the help of slope, we can also calculate. What if the points are collinear? Okay, because if they are collinear, they should have a same slope, correct? We'll look into that condition now. See the case? Here you have x and y axis. Okay, now let's take a case where we have 3 points. Okay, so let's assume that we are going to have, see, you have a line. So let's assume that this is going to be the line. So in this line, let's assume that there are 3 points. Say this is A, say this is B, and say this point is C. So we have A, B, C. Now to prove that these 3 points are collinear, it's very easy. Slope between AB, slope between BC should be equal to slope between AC, isn't it? That means M of AB is equal to M of BC is equal to M of AC. This is basically the use of slope, especially in solving problems. Okay. Now, whenever you have lines, intersecting lines, or any sort of lines, parallel, perpendicular, or if the points are collinear, whatever it is, we can make use of these, concepts of slope, and we can easily solve the problems. So in the next video, we'll look into the problems related to slope.